So in this screencast video, we're just going to have a look at this particular question, which is about shapes of molecules. And even though we've not particularly used thallium before, okay, we can be clear that thallium has 3 valence electrons because it's in group 3 of the periodic table, and it reacts with many halogens to form many compounds and ions. Now, my thought process at this point would be, okay, well, we know that we're dealing with the halogens, and the halogens, for example, chlorine, we know have 7 valence electrons, so they only need 1 electron in order to form a covalent bond. Now, we've not come across perhaps these particular ions before, but that's okay. The question asks you to draw the shape of this ion here, okay, and this one as well. Include any lone pairs of electrons that influence the shapes. So at this point, I'm thinking, okay, well, I know lone pairs provided added repulsion, and that these reduce the bond angle by 2 degrees to 2.5 degrees as a result. Oh, not degrees Celsius though. So name the shape made by the atoms in this first ion, but we don't actually need to name the shape of the second one. So I would always start by saying, okay, well, I've got my thallium atom in the middle, and that's me, my central atom, and I know that it's got 3 valence electrons. However, due to the 2- charge, I'm going to add 2 more electrons. Therefore, by adding 2 more electrons than protons, I can be sure that I'm going to get my 2 negative charge. We don't know where that 2 negative charges come from, but by using this process, it will enable us to determine the correct shape. So, here come my bromines. 1, 2, 3. You don't have to draw the rest of those valence electrons in the bromines, but I'm drawing them just for clarity at the moment. And then we're left here with these 2 electrons, which will form 1 lone pair. So here we've got 3 bonding pairs and 1 lone pair. Now that totals 4 pairs of electrons in total, which we know 4 bonding pairs would be tetrahedral, and that the bond angle here would be 109.5 degrees. However, this lone pair influences the shape, and hopefully from and other good examples for this are ammonia. Okay, so it's worth keeping that in mind, and phosphorus with 3 hydrogens bonded to it as well. So here we go, is the thallium atom in the middle, and we know that we've got a lone pair, which I'm going to pop at the top there. And then we've got the resulting shape of this, which you should remember is pyramidal, or you could call it distorted tetrahedral. And here, 109.5 minus 2 to 2.5 degrees means that you're looking at a bond angle of 107. So there's the first mark, or the first part of the question. Now the second one is asking you for the following ion. So in the same way, thallium in the middle, 1, 2, 3, for being in group 3. And then due to this 3 negative charge, we're going to add 1, 2, 3. We know we've got 4 chlorines coming to bond with it, so let's go 1, 2, 3, 4. That leaves us with 1 lone pair. So let's just say, well, if we had 5 bonding pairs, that would mean it was a trigonal bipyramidal structure. And we would have 3 angles of 120 degrees and 2 bond angles of 90 degrees. However, in this case, we've got 4 bonding pairs and 1 lone pair. Now, we've not named this structure before. The question does not ask you to name it, it just asks you to draw it. So I would draw the thallium in the middle. And then start to construct your trigonal bipyramidal structure, okay, but just replace one of the bonding pairs with a lone pair. So chlorine, okay, and the bonding pair we're going to position there, okay, because these two chlorines here that I just highlight in green, okay, are only 90 degrees away from this thallium, whereas these chlorines around the edge are 120 degrees away from another. So by positioning the lone pair here, okay, it helps to minimize the repulsion, okay, by positioning itself furthest away from another atom or from another bonding pair. Okay, so I hope that helps. Let me know if there's anything else I can do.